energy. Internal energy is represented by delta E. Internal energy is represented by delta E. Delta E. Why change in internal energy is represented by delta E. Change in internal energy is represented by delta E. So internal energy is present in substance, and internal energy is the sum of the potential energy and kinetic energy. You should also know the formula of internal energy, which is internal energy is equal to there's a trick in this formula in chemistry and physics, but it's just the same thing. But for chemistry, let's stick to this. Change in energy is equal to Q plus W, where E is internal energy. Change in E is change in internal energy. Q is quantity of heat, while W is work or work done. So there's something you need to know. When they say quantity heat is added to the system, if heat is added to the system, then Q is positive. And that's when heat is added to the system. If heat is added to the system, Q is positive. If heat is removed from the system, or it is evolved, that means it comes out from the system, then Q is negative. And Q is negative. Now, when is work positive? When is work negative? Work is positive. Work is positive when work is done on the system. So when work is done on the system, on the reaction, work is positive. So that's when work is done on the system. Work is positive. Why when work is done by the system, and when work is done by the reaction, when the work is done by the system, then work done is negative. So when work is negative, when work is done by the system, work is negative. So this is what you need to know. You need to know a formula, and you need to know all this, because if you don't know all this, you won't be able to solve any question, or you solve the question and you miss it. This question number 1, question. So they said a gas absorbs 35 joule of heat and does 15 joule of work. What is delta E? I'm asking for what is change in internal energy. So you can pause the video and solve it. So this is the solution. You're asking for delta E. What's the formula for delta E? Change in E is equal to Q plus W. So now the problem you are going to have if you don't understand how to solve this is sign problem. That means you will not know where to put minus, where to put plus, and those are the major problems most people have in solving questions like this. So they said a gas absorbs 35 joules. So I explained that when it is added, it is positive. That means quantity of energy Q is positive. So they say something absorbs. Of course, this is just simple English. When something absorbs, that means it's added to it, it absorbs it. So that's positive. That means Q is plus 35 joule. You can see both work done and both quantity of heat and work done, they are in joule, because energy is in joule, that's heat energy, and work done is also in joule. So those are the units. I didn't mention that, I'm mentioning it now. So let's get back to the question. I said it does 15 joule of work. I explained that when it does work, it is negative, but when work is done on it, it is positive. But now they are saying a gas absorbs 35 joule of heat and that same gas does work. It does 15 joule of work. That means it does work. That's W is minus 15 joule. So W is minus 15 joule. So it's very easy. We've gotten our answer. Just put it into this equation and you get delta E. So delta E is Q, that's plus 35 joule, plus 35 joule plus minus 15 joule. So that's 35 plus and minus is minus 35 minus 15. Can you see that? Yeah, 35 minus 15, which is 20 joule. Change in internal energy is also measured in joule because it's energy. So change in E is 20 joule. So that's the answer. What you just need to know is when you add it, Q is positive. When it is evolved, Q is negative. When it does work, W is negative. When work is done on it, W is positive. Is another formula for work. Another thing is another formula for work. So you know that work is force times distance, right? There is a way they derive it, but I won't be deriving it now because you just need to know the formula. So this is the formula for work. Minus, it's actually PdV. It's actually PdV. But when we are considering external pressure, that's when we use minus PX dV. We have to know as reversible processes and irreversible processes. Yeah, so minus PX dV, this is one you should know, and this is the one you are going to use to solve questions. And there's also what we know as free expansion. When something is expanding against pressure, but there's no pressure acting on it. It's just expanding without any pressure acting on it. So for a free expansion, this external pressure is 0 because it's just expanding, nothing's acting on it. So this external 0 is 0. That's for free expansion. Let me write it. For free expansion, Px is 0. That's for free expansion. Px is 0. And if Px is 0 for free expansion, work done is 0 because 0 times dV, everything is 0. 0 times volume is 0. You should know that. So let me solve one question in this slide, explain it, and we'll get it once and for all. Yeah, so here's the question. You can solve it if not solve it. So let's go. So when you see a question like this, the first thing to do is to convert the atmosphere, convert the pressure and the volume. You know the formula is work done is minus Px dV. That's the formula. But we want to convert atmosphere to Pascal because that's the pressure we can use. We don't use atmosphere, we use Pascal. I know 1 atmosphere is 10325 Pascal. So 10 atmosphere will be 10 times 10325. Or we can just say 10 raised to the power 5. You understand? I don't know the value. You don't need to know the value. Just say 10 raised to the power 5. But let's use 10325. So that will be minus the pressure 10325 times volume. The volume we are going to use will convert this liter into meter cube. And we know 1000 meter cube is 1 liter. We know 1000 meter cube. 1000 meter cube is 1 liter. Understand? So 1000 meter cube is 1 liter is 0.001 meter cube. That's 1 liter. 1 liter is 0.001 meter cube. So we are taking it to meter cube. So that will be the change in volume is 2 minus 1, V2 minus V1, that's 2 minus 1, that's 1, that's 1 liter. So 1 liter is 0.001 meter cube. That's 0.001 meter cube. So when we do this, we are going to get, this will be 10 times 101,325. The 11325 divided by this times 0.001 is just like 10 divided by 1000. So that's divided by 1000. So 1013.25. So that will be the answer. That will be minus 1013.25 joule. So that's the answer. 1013.25 joule. The negative here is just signifying that the system is doing work. So this is the joule. So you should just know the first thing we need to do is convert out. When you are giving atmosphere, convert it to Pascal. When you are giving liter, convert it to meter cube. And you should know that 1 liter is 0.001 meter cube. Understand? Or saying 1000 liter is 1 meter cube. So when you do that, you just input it into this formula and you get your answer. It's as easy as that. But now you are saying you should also express it in calories. This is very easy. Write this because I'm about to clean it. So you just need to know the conversion value. So 1 calorie is 4.184 joule. 1 calorie is 4.184 joule. Now, how many calories? Our answer is 113.25. Yes, so how many calories? X calorie. How many calories now? 1013.25 joule. So what you just do is you cross multiply. And then you take this X calorie will be now X calorie, you just cross multiply like this. So X calorie will be 1013.25 over 4.184. And you solve this and you get your answer. So that's the answer. Our answer is 242 joule. Approximately 242 joule. There are also some decimals, but approximately it's 242 joules. So that's the answer to this question. So that's how to solve question on work done minus Px dV. P external pressure minus P external pressure dV. What I just finished teaching you is work done on isobaric process, that's external pressure. That's when you use minus Px dV. There's also a way to find work done in an isothermal process. So it's also a different approach. You don't use PDV. Now you use what I'm about to show you. Now to know if you see a question, to know if it is isothermal or isobaric, as constant pressure and constant temperature. If it is isothermal, they will say something like the temperature is kept at. If it's kept at, that means it is constant at. So you use isothermal. So the formula for isothermal, work done in an isothermal process, is all these minus all these there. So minus nRT ln V. So this is the formula. Minus nRT ln V2 over V1. You can also put it in log, but it doesn't mean you're going to use your calculator, so you can just use it as ln. Ln is natural log. And you should also know this, just put this at the back of your mind. It can be used in chemistry, physics, mathematics, anywhere. Ln x is 2.303 log x. Ln x is 2.303 log x. So instead of writing this ln V2 over V1, I can just write 2.303 log V2 over V1, but you can just use ln because natural log is present on your calculator and you are free to use your calculators. So it can also present itself as this. It can also come like this. Log V is equal to minus nRT ln P1 over P2. P1 over P2. So it can also come as this. Now, why is all this also equal to this? Let's just show that briefly. So you know in this formula, this Boyle's law formula, P1 V1 is equal to P2 over V2. P1 V1 is equal to P2 V2. That's P1 times V1 is equal to P2 times V2. So, man, I'm getting dark. You are a son. So let's get back to the video. P1 over P2, P1 over P2, when you bring this pressure here, divide this pressure here, so that P1 over P2 is equal to, when you take this V1 down, that's V2 over V1. So you can see that's why we have this and we have this. P1 over P2 is equal to V2 over V1. So there's a time they will give you pressure. They will give you pressure 1, they give you volume 1, they give you pressure 2. They now say you should find the work done in the isothermal process. So instead of using Boyle's law to solve for V2, then you now do V2 over V1. You can just use P1 over P2 straight and vice versa for volume. I hope you understand what I'm saying. All I'm trying to say is P1 over P2 is equal to V2 over V1. Keep that in mind.